Angle and line relationships. Vertical angles are angles that are directly across from each other when two lines are intersecting. So they are opposite of each other. So in this example, angle 1 is congruent to angle 2 because they are vertical angles. And what congruent means is that their value for their measure is the same. When we talk about adjacent angles are angles that are right next to each other, but they don't overlap each other. So they don't go over each other in any way. In this example, the measure of angle ABC, the whole thing, is equal to the measure of angle 6 plus the measure of angle 5. When we're talking about complementary angles, complementary together equal 90 degrees. Supplementary together equal 180 degrees. So a straight line is 180 degrees. So we'll use supplementary a lot when we're talking about straight lines. Now, when we're talking about complementary in this example, the measure of angle 7 plus the measure of angle 8 should be 90 degrees together. So if we find the value of one or the other, we can find the second angle by subtracting 1 from 90. With the supplementary ones, if we have a straight line and we have one that's measure of angle 9 plus the measure of angle 10 should together equal 180 degrees. These are just the pairs of angles that we talk about. The next thing is perpendicular lines, and that's a special rule. If you have two perpendicular lines, the way that you'll write that is you'll put an upside down T. That's what means perpendicular when you're writing it. So in this case, L is perpendicular to M. If we have an example of a straight line, and we're trying to figure out what the angle equals if we're given one angle. So it says if the measure of angle Y equals 135 degrees, what is the measure of angle X? Well, 180 minus 135 should give us X, which is 45. So we would say the measure of angle X in this case is 45 degrees. Now we have some new things that we're going to talk about. Two lines don't ever intersect. Those are called parallel lines. Now if we take two parallel lines and we draw a line through them, it's called a transversal. And that transversal will then give us some different kind of special angle relationships. Now those special angle relationships involve alternate interior, which if you look at this alternate interior, 3 is alternate sides of the transversal, which is L in this case, if you see that, of the parallel lines, which are J and K. Now, the interior, 3 and 5, are alternate sides of the transversal, and they're both inside the parallel lines. So 4 and 6 are also alternate interior. Now, alternate exterior means they're outside of the parallel lines, but they're still on the opposite sides of the transversal. So in this case, 1 is congruent to 7, and 2 is congruent to 8. Corresponding angles are angles that are in the same position on each parallel line. So angle 1 and angle 5 are corresponding because they're in the same position on each parallel line. Angle 2 and angle 6, angles 4 and 8, and angles 3 and 7. And they're all going to be congruent to each other if they fall into those categories. So if we're looking at this example, we have two parallel lines that are cut by the transversal, and we can look at the measure of angle 1, if it equals 120 degrees. If that's something that we're given, we can identify what the measure of angle 2 is by using supplementary angles, because together they create a straight line. So the measure of angle 2 would then be 180 minus 120. So the measure of angle 2 is 60, and the measure of angle 1 is 120. So using that information, we could then say angle 2 and angle 3 are vertical angles, and if we recall, vertical angles are ones that are across from each other when two lines are intersecting, and they are therefore congruent, which means that the measure of angle 3 is also 60 degrees. Now using that information, the measure of angle 2 and the measure of angle 6 are corresponding. Now remember, that means they're in the same position on each parallel line. So that means they are also congruent, so the measure of angle 6 is also 60 degrees. If we look at that, use that same information, the measure of angle 1 and angle 8, because they're alternate exterior, meaning that they're on the opposite side of the transversal on the outside, that makes them exterior. So the measure of angle 1 and the measure of angle 8 are going to be congruent. Therefore, the measure of angle 8 is also 120 degrees. So angle 3 and angle 6 are alternate interior, and because of the information that we already found, we know that they're both 60 degrees. So that means angle 5 and angle 4 are also alternate interior, and they would have to equal 120 degrees because of the corresponding angles that we have, that we've already been given, or because of the vertical angles. We've kind of established a lot of situations here. If we're given an angle and we're told to figure out what the value of the smaller angles within this larger angle are, so we're given two adjacent angles. They don't overlap. They are connected, but they are not overlapping. So ABD, if we look at that, ABD equals 164 degrees. That means the entire thing altogether equals 164 degrees. And it wants us to find ABC and CBD. So as we can see, ABC is 2x plus 23 degrees, and CBD is x degrees. So together, they make 164. So if we put that all together and add it, 2x plus 23 plus x equals 164. And we simplify by combining like terms. So 2x plus x is 3x, and then leave that plus 23. Altogether still equals 164. Now to get the x by itself, we need to start subtracting that 23 from both sides. That leaves us with a 141. So 3x is what we have left on the left side, equals 141. To get x by itself, we would then divide by 3, and we would get x equals 47. Now, we know what x equals, so we take that 47, and we have to go plug it in into the 2x plus 23. So 2 times 47 plus 23 is going to be the angle ABC. So we end up with 170 degrees for ABC, and CBD we end up with 47 degrees.